Okay, we're going to have a look at covalent bonding, but we need to look at a specific aspect of covalent bonding, and that is the dative covalent bonding. So first of all, what we'll do is have a quick recap of regular covalent bonding. Here I've got two chlorine atoms, and on them I've added their outer electrons, and you'll notice that chlorine has a gap here, and this chlorine has a gap here, and the idea is this chlorine can have this electron moving across to here, and this chlorine can have an electron moving across to there, sharing electrons. So we get this, where here are our two shared electrons. Those two electrons end up being our covalent bond, single covalent bond. 2 electrons is one covalent bond, 4 electrons is double bond, and 3 electrons would be a triple bond. That's all fine. The key point, I guess, that we need to highlight is that one electron here has come from this chlorine atom, and the other electron here has come from this chlorine atom. So if we now look at the dative covalent bonding, I want to consider ammonia, NH3, producing NH4+. For that to be the case, ammonia needs to react with H+ ions. We'll turn that into a dot-cross type diagram. There's the ammonia molecule. We need to consider the hydrogen ion. Hydrogen atoms have one electron in its outer shell. If it's a hydrogen plus one ion, it's got no electrons in its outer shell. So essentially we can draw that like this. And you'll notice here, nitrogen has what's called a lone pair of electrons. They're non-bonding, and they're there. Hydrogen has no electrons in its outer shell. So, bearing those two in mind, we can draw this. So there's my ammonia again. Let me just select this. And that happens there. So you'll see we've got 1, 2, 3, 4 bonding pairs, which means that we end up having something that looks like this overall. This bond here is this set of electrons here, and both these electrons here have come from the nitrogen. We can show that on our diagram by adding an arrow in there. And it's important to say that those 4 bonds down here now are completely indistinguishable from each other. That's just nitrogen bondage to hydrogen 4 times. Okay, we're going to have a look at one more example now. And the example that we're going to look at is aluminium chloride. The formula of aluminium chloride is AlCl3. And just in terms of atomic masses, we'd have 27 plus 3 times 35.5. And that's going to equal, do it in my head on the calculator which is next to me, 133.5 grams per mole. Okay, but oddly, when we do some analysis on aluminium chloride, we find the relative molecular mass of aluminium chloride is precisely 267 grams per mole. So this one here is actually wrong. You'll notice that's double that, and therefore we garner that the fact that aluminium chloride is actually Al2Cl6, and we need to work out why that's the case. So we need to look at the dot cross diagram for aluminium chloride AlCl3 first, and here it is. And you can see that we've got single covalent bonds here, and chlorine has got 8 electrons in its outer shell. Aluminium's only got 6 electrons in its outer shell, and it's got space here. It's electron deficient. Chlorine over here, and here, and here, is relatively electron rich. It's got lone pairs here, non-bonding pairs. Aluminium's got a space for a non-bonding pair. And what I'm going to do is just copy that, but rotate it round. And the reason I'm rotating it round is because of this. If we do that, you'll see here chlorine was able to donate one of its lone pairs to aluminium, which was electron deficient. So the chlorine was electron rich, the aluminium was electron deficient. Similarly here, this aluminium was electron deficient, this chlorine here was electron rich, so the chlorine donates its electrons to the electron deficient aluminium. It looks fairly complicated from that diagram, but we can simplify it by saying something like this, or drawing it in this kind of way. So there we have this AlCl3 over here, this AlCO3 over here, and that's going to look like this. And this is our dative covalent bond where chlorine gives its electrons to aluminium, and this is our dative covalent bond where chlorine gives its electrons to the other aluminium. I hope that makes sense.